Hello friends, in today's video we are going to learn how to find principal values of inverse trigonometric functions. Before proceeding, let us understand this example. In this example, cos inverse minus 1 to 1, that is nothing but this is a domain value and it is a range value. So here is a domain and here is a range. Here is a domain, here is a range. So there are the multiple value of the range. Out of this, one we have to select. One unique value we have to select. This is the first result. This is the second result. This is the third result. If you move further, you will find more results for the range. Out of so many range, we need to select only one unique range, unique value. We have to select one unique value. So that unique value is nothing but called principal value branch. So out of so many range values, one unique value we have to select. How to select that? That can be selected on the basis of this statement. What is the statement? The principal values of trigonometric functions are the solutions in which theta lies between 0 and 2 pi. Theta is greater than 0 and less than 2 pi. So out of these values, we have to select that range value in which theta is greater than 0 and less than 2 pi. You see here theta greater than 0, no, this condition, because it is theta here is a minus pi is there. So this range value cannot be selected. Here pi to 2 pi, okay, theta has to be greater than 0 and less than 2 pi, but here it is a 2 pi. So this value even we cannot select. So we can select the first value 0 to pi. So this unique value is nothing but called principal value branch. So this is the principal value branch, because here theta lies between, theta is greater than 0 and theta is less than 2 pi. So the first value of the range is selected as a principal value branch. Here I got inverse trigonometric functions and their principal value branch. And for the sine inverse function, the principal value closed interval minus pi by 2 to pi by 2. The closed interval means what? The theta is here greater than or equal to minus pi by 2 and less than or equal to pi by 2. That is the meaning of closed interval. So similarly for the cos inverse, the principal value closed interval 0 to pi, tan inverse open interval. This is the open interval. That means theta is greater than minus pi by 2 and theta is less than pi by 2. It is the open interval. So for cot inverse 0 to pi, for the sec inverse closed interval 0 to pi minus pi by 2, and for the cosec inverse here is a closed interval minus pi by 2 to pi by 2 minus 0. We are going to solve the problem to find the principal values of various inverse trigonometric functions. I am going to solve some problems for you. For that you need a chart. So I request you pause the video for a while and write down this chart in your notebook. And you need to write one more chart in your notebook. This is the chart. This is a basic trigonometry. For example, sin 90 minus theta equals to cos theta, tan 270 minus theta equals to cot theta, cosec 360 plus theta equals to plus cosec theta. This is an important chart. Even we are going to use this chart to find out the principal values of inverse trigonometric functions. So I request you that even the chart you write down in notebook, pause the video for a while and write down these values. Question number 1, find the principal value of sine inverse of minus 1 by 2. So what you do? You have to find the principal value. For that, solution. Under the solution, let sine inverse of minus 1 by 2 equals to y. So it implies sine y equals to minus 1 by 2. This is step number 1. So this can be written as minus 1 by 2 can be written as minus, and here is a 1 by 2 here. Now after that you go to the table. So in this table, trigonometry table, we are having sine 1 by 2, that is 30 degrees. So here is a sine 30 degrees equals to 1 by 2 from this chart. So what you do now, you will go back that step. You will go back here, and in place of 1 by 2, in place of this 1 by 2, you will write sine 30, because sine 30 is 1 by 2. 30 can also be written as a pi by 6. So it is a sine pi by 6. So this is equals to minus sine pi by 6. You know that minus sine theta equals to sine of minus theta. Therefore, this can be written as sine of minus pi by 6. What is the LHS? LHS is a sine y. This is equivalent to sine y. Comparing both sides, we get y equals to minus pi upon 6. So we got the value of minus pi upon 6. Now we need to decide, is it the principal value? How to decide? Is it the solution or not? For that, you need to go to the table back. In this table, the principal value branch for sine inverse function is greater than or equal to minus pi by 2, less than or equal to pi by 2. And our result is y equals to minus pi upon 6. So minus pi upon 6, that is greater than minus pi upon 2 and less than pi upon 2. That means our result lies between minus pi by 2 and pi by 2. Therefore, we can accept this result. Therefore, the principal value of sine inverse of minus 1 by 2 is minus pi upon 6. This is the solution. Suppose here this minus is not given. So need to find the principal value of sine inverse of 1 by 2. So the step is remaining same. Sine inverse here, sine inverse of 1 by 2 equals to y. So sine y becomes 1 by 2. This minus will go away. This minus will go away. This minus will go away. And this minus will go away. After that, step is remaining same. Here the sine 30. Sine 30 is nothing but pi upon 6. Here is a sine theta equals to sine theta. Minus will just remove out. This minus is also gone here. This minus is also gone here. And sine y equals to pi upon 6. Here is a, in place of minus there is a plus. The minus will go away. Pi by 6, that lies between the minus of pi by 2 and pi by 2. Therefore, y equals to pi upon 6 is a principal value of the given question. Therefore, principal value of sine inverse of 1 upon 2 is pi by 6. Example 3. Find the principal value of cos inverse of root 3 by 2. Solution. First of all, we write down cos inverse of root 3 upon 2 equals to y implies cos y equals to root 3 upon 2. Now, from the chart value, cos root 3 upon 2 nothing but 30 degrees. So we'll go back. So root 3 upon 2 nothing but cos 30 degrees, and 30 degrees can be written as pi upon 6. So cos pi upon 6 equals to root 3 upon 2 implies cos y equals to cos pi upon 6. Comparing both sides, implies y equals to pi upon 6. So is it the principal value or not? For that you need to go back to the for cos inverse function. The branch value is theta is greater than or equal to 0, less than or equal to pi, that is closed interval 0 to pi. So our result is pi by 6. So this pi by 6 we can accept as the principal value. Therefore principal value of cos inverse of root 3 upon 2 is pi by 6 is the required solution. Question number 4. Find the principal value of tan inverse of minus root 3. Solution. Let tan inverse of minus root 3 equals to y. Therefore tan y equals to minus root 3. Minus root 3 can be written as minus here and root 3 inside the bracket. After that, we need to see this table and tan 60. Tan 60 equals to root 3. See here in this table, tan 60 equals to root 3. So in place of root 3, we can write tan 60. 60 is equals to pi by 3. And we know that minus tan theta equals to tan of minus theta. Therefore tan y equals to tan of minus pi by 3 implies y equals to minus pi by 3. Now from this table of principal value branch, the tan inverse, for tan inverse, the values for principal value branch, theta is greater than minus pi by 2 and theta is less than pi by 2. So theta is greater than minus pi by 2 and theta is less than pi by 2 from principal value branch, and minus pi by 3 is greater than minus pi by 2. Therefore y equals to minus pi by 3 can be accepted as a principal value. Therefore principal value of tan inverse of minus root 3 is equals to minus pi by 3. This is required solution. Find principal value of cos inverse of minus 1 by 2. Solution. Quite simple problem. Let cos inverse minus 1 by 2 equals to y. So cos y equals to minus 1 by 2, and we know that cos pi by 3 equals to 1 by 2. So this minus 1 by 2 can be written as minus, and here is the 1 by 2. So cos y equals to minus as it is, and in place of 1 by 2 cos pi by 3, and we know that cos 180 minus theta equals to minus cos theta. Therefore cos y equals to cos pi minus pi by 3 equals to cos 3 pi minus pi upon 3 equals to cos 2 pi by 3. Therefore cos y equals to cos 2 pi by 3, comparing both sides, so implies y equals to 2 pi by 3. Now is it principal value or not? To decide, let us visit the table according to principal value branch, for the cos inverse, the principal value branch, the values lies between theta greater than or equal to 0, less than or equal to pi. Theta is greater than or equal to 0, less than or equal to pi, and 2 pi by 3, that is, this is greater than 0, and 2 pi by 3 is less than pi. Therefore, y equals to 2 pi by 3 we can accept as the principal value. Therefore, principal value of cos inverse of minus 1 by 2 is 2 pi by 3. Number 6. Find the principal value of sec inverse of 2 upon root 3. Step number 1 is as it is, that let sec inverse of 2 upon root 3 equals to y. Therefore, sec y equals to 2 upon root 3. This is nothing but, from the table, sec 2 upon root 3 nothing but 30 degrees. So sec y equals to sec 30 degrees, that is sec y equals to sec of pi by 6, implies y equals to pi by 6. We need to decide, is it principal value or not? For that, we need to see the table for the principal value branch for sec inverse. Principal value branch for sec inverse is 0 to pi minus pi by 2. So implies theta greater than or equal to 0, less than or equal to pi, minus pi by 2. So we got here the answer. We got the answer pi by 6. Therefore, principal value of sec inverse of 2 by root 3 is equals to pi by 6. This is the answer. Example number 7. Find the principal value of tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. So we'll make the 3 column here. In the first column, we write down, let tan inverse of 1 equals to x. Second column, let cos inverse of minus 1 by 2 equals to y. In the third column, let sin inverse of minus 1 by 2 equals to z. After that, implies tan x equals to 1, cos y equals to minus 1 by 2, sin z equals to minus 1 by 2. After this, we will find principal values for each. Now we find the principal value individually for each function. So I got here the principal value for tan inverse 1, that is x equals to pi upon 4, and for cos inverse of minus 1 by 2 I got y equals to 2 pi upon 3, and for sin inverse of minus 1 by 2 equals to z, I got z equals to minus pi upon 6. I got all these values as per as the previous discussion. Now the total principal value for entire function can be obtained by adding x value, y value and z value. Therefore, principal value of tan inverse 1 plus cos inverse minus 1 upon 2, sin inverse of minus 1 by 2 equals to x plus y plus z, x value pi by 4, y value 2 pi by 3 and z value minus pi by 6, which is equivalent to 9 pi upon 12. So that is equals to 3 pi upon 4. This is required solution. Example 8. Find the principal value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Solution. First of all, we make two columns. One for cos inverse 1 by 2 and another for sin inverse of 1 by 2. Now we'll find out principal values for both. Let cos inverse 1 by 2 equals to x. So cos x equals to 1 by 2. Let sin inverse of 1 by 2 equals to y. So we get sin y equals to 1 by 2. Now cos x equals to cos pi by 3 implies x equals to pi by 3, and sin y equals to sin pi by 6 implies y equals to pi by 6. We got the x value, that x equals to pi by 3, that is pi by 3 greater than 0 and less than pi. Therefore x equals to pi by 3 is the principal value of cos inverse of 1 by 2, that is accepted. Similarly, y equals to pi upon 6, which is greater than minus pi by 2 and less than pi upon 2. Therefore y equals to pi by 2, pi by 6 is the principal value of sin inverse of 1 by 2, that is even accepted. Therefore principal value of cos inverse 1 upon 2 plus 2 sin inverse of 1 upon 2 equals to x plus 2y, that is equals to pi by 3 plus 2 into pi by 6 equals to pi by 3 plus pi by 3 equals to 2 pi by 3. This is required solution. So after going through this video, I hope you can now solve the problem related to principal values of inverse trigonometric functions. Try to solve more questions from your textbook. If you are unable to solve them, please contact me on my email address provided in the description box. Meet you again with another topic. Before saying goodbye, I would like to request you like, share and subscribe the channel. Meet you again with another topic. Till then, wish you good luck. All the best.